Let's look at this problem. This is a little bit different than the other examples we've done. This one right here, we do not know what P is. In fact, we need to solve for P. We are given the condition that all the members, they can support a maximum of 8 kilonewton in tension and a 6 kilonewton in compression. So based on this condition, we need to determine what maximum applied force P that this structure can sustain. So how are we going to solve this problem? We're going to treat P as a known parameter, and we're going to carry it through, and we're going to solve for all the force member in the truss members as expressions of P, and then we're going to compare the results. So the first thing we want to do is to, again, identify zero force members. In this case, we have member CD and member BC, two members joined together at point C, and they are at an angle, they are not collinear, and very important, there's no other forces or couple moment acting at point C. Therefore, both member CD and BC are zero force members. And that would not be changed by the magnitude of P. So now, with that simplification, we're going to try to solve for the forces in all the remaining members as expressions of P. So we're going to start with joint D, because joint D now only has two unknowns, which are member DE and member BD. So we're going to start with joint D, draw its free body diagram. We have P right here, and then we have two other unknowns, FBD and FDE. Now keep in mind that we are going to treat P as a known parameter. So along the x direction, Fx equals to negative FDE, and that equals to 0. Resultant force along the y direction equals to negative P minus FBD, that equals to 0 as well. So again, I'm using conventional x and y coordinate system. So from there, we can solve for FDE, that is always a 0, and then FBD, that equals to negative P. All right, and we're assuming that the direction of P is for sure always vertical down. Therefore, FBD must be a compressive force. So now we have solved for BD and DE. All right, moving on, we can solve for joint B. At joint B, we have member BD. We have already solved for member BD. It has a compressive force with a magnitude of P. Remember, we're still treating P as if we know it. And then we have unknown FAB, and also another unknown FBE. And recognize again, this is we have this 3, 4, 5 triangle here. So this is 3, 4, and this is a 5. Therefore, along the x direction, we have negative FAB minus FBE with a component of 4 over 5 equals to 0 along the y direction. So again, still using conventional xy coordinate system. We have positive FBE with a 3/5 component minus P equals to 0. So two equations. From the second equation, we can solve for FBE to be 5 over 3 of P. At this point, it's not necessary to evaluate this. Remember, this is still intermediate steps. This is leading us to the final result, but this is not the final result. So there's no need to evaluate 5 over 3. Let's just keep it like that. and substitute that into the first equation, and we can solve for FAB to be negative 4 over 3P. So if it's negative, that's compressive. If it's positive, that's tensile. So now we have solved for two more forces, these and these. At this point, if you look at joint A, you realize that because we have a roller support here, there's only one force reaction, and the direction is known. It has to be horizontal. Therefore, the force FAE is going to be the only vertical component along the y direction. Therefore, from there, we can determine that FAE is also 0. So now we have already solved for all the forces in all the truss members, not as absolute values, but as expressions of P. So FCD, FBD, FDE, and FAE are all zeros. So what remains are, we have FBD equals to negative P, FAB is negative 4/3 P, and FBE is positive 5/3 P. Therefore, moving over here, maximum tension force can only be FBE, because FBE is actually the only one that is in tension. Therefore, I'm going to set FBE, which equals to 5 over 3P, to be the maximum allowed force, which is 8 kilonewton. From there, I can solve for P max, but remember this is determined by the tension, to be 4.8 kilonewton. But what is the maximum compression force in the truss members? We have two members that are in compression, FBD and FAB. But because FAB is larger, therefore FAB can be the maximum compressive force, which equals to negative 4 over 3P, which equals to compressive 6 kilonewton force. From there, we can solve for P max from compression to be 4.5 kilonewton. So at this point, you realize that we have solved for two P max, and they're not the same. So this is the P max that we solved for under the assumption that the structure is going to fail due to too much tension force. This is the P max that we solved for under the assumption that the structure is going to fail under maximum compressive force. And now we compare these two, and the final answer must be P max equals to 4.5 kilonewton. It has to be the smaller one, because how do we interpret the results? The results show that when P has reached 4.5 kilonewton, remember P is still this applied force right here. When P has reached this 4.5 kilonewton force, then FAB has already reached the maximum 6 kilonewton compressive force, and member AB will fail. So if P is actually 4.8 kilonewton, member AB would have already failed, because the the compression force in member AB would have developed to be more than 6 kilonewton when P equals to 4.8 kilonewton. Therefore, it's the smaller one that controls.